Hello, I am Nitesh Pradhan from LabVIEW Programming. In this session, uh, I will show you how can we acquire, display and log the vibration data. So for that, we will use 9232 and Flex Logger. 9232 is a sound and vibration module. It is C-series sound and vibration module which we can use for the vibration data measurement. Right now, I don't have real hardware. So in place of real hardware, I will simulate a virtual hardware, and after that I will show you how can we acquire the sound and vibration data. So for that, first open your NI Max, because as I mentioned, I don't have real hardware. So in place of real hardware, I will use the virtual hardware. And we know very well, to use C-series hardware, we need C-series chassis. If you don't have a real hardware, so how can you learn the data acquisition programming? So for that, open your NI Max, come into the device and interface, click here, come into simulate NIDAQMX driver or modular instruments, press finish button. It will take few seconds, then you will get a configuration window. Now you can see I am getting this create simulated NIDAQMX window. Now here, let's try to find C series. I'm not able to find the direct C series any hardware. So here I can write 9174. If I want, so I can use 9171, 9174, 9178 or 9179. 9179 is 14 channel slots. It is 8 channel, it is 4 channel single channel slot. So I will take 9174. Let's take 9174. Now you can see here it is a 9174 module, 9174 chassis. When you will click the 9174 chassis, so you will get NIC Tech 9171. It's simulated, it's present in the PC. Let's try to configure the simulated chassis. When you will try to click the configure simulated chassis, so you will get 4 slots. In the first slot, I'm going to click here NI9232. Select NI9232, NI9232 BNC. Just a second, NI9232 BNC. Yeah, NI9232 BNC. Okay, press it. Now you can see in this slot number 1, NI9232 I have simulated. Slot number 2, 3 and 4 are empty. Now come and open the flex logger. When you will open flex logger, so it will take few seconds. After that, you will get flex logger window like this. Right click and come and create a new project. When you will create a new project, so it will take few seconds and it will open a very beautiful GUI for you. Flex logger is a programming free data logging platform. Now you can see here, when I create a flex logger projects, so after that you can see here flex logger automatically detected all the possible hardware which is present in my, which is connected or which is simulated, okay, in this my PC. Now you can see here the it's by default showing CDAQ 9174 simulated. In the slot number 1, you can see 4 counters, onboard counters are here. Now you can see NI9232 BNC sound and vibration input modules. Okay, sound and vibration input module, and it's a 3 channel analog input module. So now you can see all the 3 channels are here. Now, what is the maximum sampling rate of sound and vibration input module? Sorry, NI9232. So NI9232 has the maximum sampling age is 1.2 102 102.4 102.4 kilosample. So the maximum sampling rate for NI9232 is 102.4 kilo sample per second per channel. So here I will try to get the, I will try to acquire the data. Okay, now you can see the data acquisition rate, it's already fixed slow 1 hertz. 1 hertz mean 1 sample per second, 100 hertz, fastest 1 kilohertz. But I want to acquire the fastest data 10 kilohertz. Done. Now the fastest one is 10 kilohertz. Now let's start acquiring the data. Double click here, double click here. Now you can see CDAC module 1 AI0 vibration acceleration acceleration IEPE type of sensing. I want to measure data in terms of we can measure data in terms of gravity, meter second square, okay, meter per second square, inch per second square. Let's try to check it, go with the meter per second square. Now you can see here the meter for the meter per second square, the sensitivity has been changed 1 volt per meter per second square, and hardware range is plus minus 30. Now hit the save button. Now press the done button. Now you can see here we are easily able to acquire the data. Now it's providing us the acceleration data. Let's try to configure the second channel. Acceleration, IP, now gravity, and let's try to reduce it. 0.0012 gram, sorry, volt per gram. Double click here, come here, acceleration in terms of voltage, gravity, done. All these three lines, okay, we are able to acquire the data, acceleration data in terms of gravity, in terms of gravity, in terms of meter per second square, or in terms of voltage. And the data acquisition rate is right now actual rate. Now it's showing the actual rate is 102.4 hertz kilohertz. Okay, but we are only acquiring the data with the 10 hertz. Okay, now login. Come into the screen. Now in the top of the ribbon, channel, login specification, test section, sorry, specification, screen. Come into the screen. In this screen, you will find here search, favorite, graphs, numeric, and other. Click here. Come into the high speed graph, frequency graph, okay, log graphs. Let's take the frequency, long graph. Now, whenever you will take a long graph, so automatically it will show you this window. In this window, you will get this option. By clicking this option, you can enable your all the measurements. First, now you can see only one data I'm getting. Second, I'm getting another data. Third, now you can see here. We can easily acquire. So now you can see the first one. This one is my first data. This one is my second data. This one is my third line. We are getting on all the lines. Color, can I take it blue? Not. Hmm. Just because it's long history graph, that's why the data are moving slowly. Now, in this way, you can easily display your data. Let's come into the logging the data. Here, now you can see it is my computer path, but in place of this, I can go to document. Okay, here, come here. Let's come here, come into the my video section, flex logger, FLEX flex logger. Come inside 9 NI 9232 NI 9232. Select the folders. I have selected. Now here I am going to change the name. 3 CHA channel sound, sorry, vibration data. Now you can see here it will save your data in the TDMS format, but we need data in the CSV format. So now you can see here export data in the CSV format, and I want to acquire my data the same 10 hertz, 10 kilohertz, 10 kilohertz. I want to acquire data in 10 kilohertz. Okay. Now system is ready. Run the program. Now you can see here we are easily able to acquire the data. Let's come here. Okay. Come into the videos. Now come into the flash logger. Okay. Now it's creating that file. When I will stop this program, so it will create .csv file also. Let's double click and open it. Okay. In this way, you can easily acquire, display, and store your sound and vibration data. Let's try to use. I'm going to delete this screen. Just delete. Click here and use the frequency graph and let's try. Are we get the frequency? Definitely we'll get the frequency. Now you can see we are getting the frequency. So what is the frequency? If I will try to check here, fix it 10, fix it 100, fix it 1000. Later we can work and we can examine how it is providing us the particular data. Now look at here. Why it is giving us the data? Why it is giving us the data with the 10 hertz? Why? Because you can see here Just a second. Okay. First, now you can see here. Hmm, Look at here. If you will see the frequency setting, here the window is hanging and frequency setting is 10. If I will increase it with the 10, okay, if I will increase it with the 10 kilohertz, sorry, yes, 10 kilohertz. Now, hmm, yeah, 10. Let's reduce one sample again. Reduce here one sample. Okay, now click here in this signal. Non-zero, this is linear, amplitude and frequency. Everything is fine. So here, the best way is 10, 1. Keep it 1. So whatever the maximum data we are taking, is displaying that data. So thank you for watching this video.